Now, oil and the gas. Oil is called the black gold because there's a lot of stuff like a few hundreds of hydrocarbons in a barrel of oil. And the separation of those hydrocarbons is called refinery process. And this is example what we are using from the oil. Okay, so you can see the structure. It's mainly made up from the carbons and hydrogen, no matter how it's connected, how the chemical structure look like. And similar to coal, the ancient microscopic organism in the ocean died and fall to the seafloor and got buried and converted under high pressure and heat. So it formed the oil and gas buried deep underground. It also takes 100 million years. I put a slide here to hopefully help you to understand why most of the time the natural gas and the oil are co-present. And you can see the geological structure here, how the gas and the oil were buried or sealed under the impermeable cap rock. I want to let you know that this is not a proportional depth compared to the surface. Actually, I think this is much deeper than we thought. This graph probably make people think this is very close to the ground, but actually it's not. Now concentrate on the structure here. In the face-to-face settings, I always ask students, when you cook, okay, when you make a soup, is the water underneath or the oil underneath? Because the oil is lighter than the water, so it always floats on the water. And the gas is lighter than the oil, right? So the gas is above the oil. So this is the structure here. So you can understand when you drill for oil and the water kind of push the oil out, right? So you in some of the techniques you have to inject the water, and sometimes the water just come out with the oil. And this is a huge amount of water. Sometimes the natural gas are coexisting with oil, sometimes not. But many circumstances they are. So when you have oil, you have natural gas. So it's easier to understand that. I want you to watch this fantastic video. Without watching this video, you will have no idea what I talk in the next slide. So go and watch this video, only take a few minutes, and then come back and resume the lecture slides here. Here I want to introduce the fracking. Fracking is a deep drilling. Okay, so it drills, this is 7,000 feet. 7,000 feet, it's about a few kilometers. And they use this technique, means fracking, which means breaking the space in the rock and then inject water and sand into the fissures. And after the water and the sand withdrawn, the oil and the gas will leaking into those small spaces back into the pipe. Here I want to emphasize again, you need to watch that video. Okay, after you watch the video, it's much easier to understand why we use millions of liters of water. Okay, so you have to inject a lot of water here, and then you have to recover a lot of water here. So storage of the water and the treatment of the water will be a challenge. If this is a dry area or semi-dry area, obtaining the water is an issue also. A lot of aquifers have been used heavily for agriculture use. And if this is a semi or dry area, you have to deplete the aquifers more for oil drilling. I just want you to be aware of that. So the water management is very challenging, and the water will be contaminated, okay, from the radioactive material or heavy metals and things. So how to treat the water and reuse it? That needs thorough planning. Oil and gas leaking wells that impose great environmental risk. And we have disasters, the oil and the gas leak. And I'm not going to go into details, and please read the textbook about the disasters and accidents happen. World oil reserves, mainly it's in Middle East. Middle East, I'm going to talk about this more. Middle East and the non-Arab members of OPEC control more than 70% of the oil reserve of the world. And then North America has the next largest share, which is about 15%. And look at the gas reserves, and the highest is Middle East, Europe. Oil is cleaner than coal, but still using oil release huge amounts of carbon. And oil spills is the biggest, I would say, the heaviest environmental contamination compared to all the applications of oil. And a lot of students do not realize how big impact the oil spills can have on our environment. And accidental spills only account about 1/3 of oil pollution, and 60% comes from the routine shipping operations. So if the rig exploded here, the ocean will be contaminated, and it has long-lasting impacts on the ocean. We already did the Anneberg, right? And the secondary recovery, that means if the oil do not flow freely up to the ground level, you have to use huge amount of water to recover the oil here. And sometimes the tertiary recovery, that means we inject steam, the higher temperature to make the oil flow, and higher pressure to squeeze them out to the ground level. And that the secondary recovery and the tertiary recovery is very expensive. And we use those pipes to transport oil, which is more convenient and faster than transportation of coal. And we use the tankers to ship the oil. And the natural gas usage, natural gas probably is the cleanest of all the fossil fuel, and it has a rapid rise in the market in recent years. But the challenge is it's hard to transport, and in many places it's burned off at oil fields. If you pass Baytown here, you can see those gas was constantly burned off. And so we can transport as liquid forms. Okay, we can compress the gas, and this is under this ultra low temperature, the volume is one of the 600th. The safety becomes a concern. Okay, so the explosion will be really bad. So this is an overview of natural gas use. Environmental issues, the oil spills. I want you to pay attention to these numbers. This is 500,000 metric tons. Okay, it used to be really bad. This is 3,000. This is 3 million metric tons spill. This is 1970s. Now it's getting better, but you have to realize the oil spill will linger in the ocean for quite a while. Okay, and this pie tells you where the spill comes from. Okay, so the using of oil and the transportation of the oil all contribute to the source of contamination in the ocean.